So today we're going to be looking at operations of functions. So operations of functions consist of four basic operations. They are addition, subtraction, multiplication, and division. And we're using those with functions. So we've got different ways that we can label a function. The way we're going to be using them are f of x and g of x. So we might change that front value. In this case, our function of f of x is going to be 5x, and g of x is going to be equal to x plus 2. So between these two, we can do all four of these functions. So our first is just f of x plus g of x. So we're going to take the function of f, which is 5x, and we're going to add to it g of x, which is x plus 2.
Hold on, what?
So all we're doing when it says we have f of x plus g of x, this is our f of x, this is our g of x, and we are adding those two things together. So the f of x plus g of x combine our like terms. So
6x plus 2.
6x plus
Equals
just it.
8x.
So we can't combine these any further, right? This is x's, this has no x, so that's a constant. You can only combine the like terms.
So the answer is just an equation.
It's just a new equation, 6x.
That's easier than I thought it would be.
So our new equation is just 6x plus 2. Our second equation, we have f of x minus g of x. So all that's really changing is the sign in between. So we have 5x for our f of x, and again x plus 2 for our g of x, and we are subtracting the 2 this time. Here's something that we need to do, though, to make sure we do it right. We want to put our g of x in parentheses because we're subtracting the entirety of g of x. So when we combine these two, or we subtract the two functions, we've got 5x minus x.
That's 4x.
Gives us 4x. And then minus a 2. We have to distribute that negative to everything on the inside.
So it's negative 2.
We get negative 2.
Where does the
Is
x
this
go?
like that bad?
Where does the x go when you distribute the negative?
So the
Oh, it's because it's only one, so when you put a negative in, it's canceled out.
Yes.
Okay.
Yeah, 'cause we're combining these two together because they're the same values.
Okay.
The next we got f of x times g of x. So again, f of x is just 5x. And we are multiplying that by g of x, which again is x plus 2. So in this case, we're going to distribute the 5x to both parts. So f of x times g of x, 5x times x,
5x squared.
5x squared plus
10x.
10x. Okay.
Now that we can do something with, right?
And that's it. We don't want to factor it because if we factored it, we'd go right back to where we start.
So
Okay.
you don't do anything with any of these.
We're expanding this out as big as it goes.
Okay.
So doing all the operations. And our last one is division. We've got f of x divided by g of x. So again, f of x is 5x. And we are dividing it by g of x. G of x is x plus 2. And 5x and x plus 2, there's nothing we can do to actually simplify that, so that's just our answer right there. Right? Yes?
Unless subtraction one, how did it go to negative 2?
Because we're subtracting the entirety of g of x, so we have to distribute that negative to both pieces of it. So that's going to give us a negative x and a negative 2,
Like, how does it work? Positive.
because it's 5x minus x gives us a positive 4x. Okay? And so really the only other thing that we have to watch out for, and that is division. And that's because at x plus 2, in our denominator, we have an excluded value. So think back to our rationals. The one excluded value that x cannot equal would be a negative 2. Because if we have negative 2 plus 2, that would get a 0 in the denominator, and we cannot divide by 0. Yes.
Okay, so if you look on the back of the homework sheet, number 19, it got like F times G and then times 10, so what do we do with that?
Okay, so we're going to get to that. Hold on. So we've got two things that we can do with our functions besides just adding, subtracting, multiplying, and dividing. The first is we can multiply our functions by a scalar. So think back when we had a matrix and we multiplied it by a scalar, we took everything inside of it and multiplied it by that value. We're doing the same thing with functions. So in this case, we have 2 f of x. So we're taking 2 times f of x, plus we've got 3 times g of x. And so what they're doing is they're taking 2 and multiplying it by the function of f of x, which f of x again is just 5x, plus 3 times our g of x, and g of x was still just x plus 2. And they're combining. So what they're doing is they're taking each function, multiplying it by a scalar out front. So 2 times 5x gives us 10x, plus distribute our 3 to everything that is g of x. So we get 3x plus 6. And then combine your like terms. So we get 13x plus 6. Okay. So that's multiplying by scalars. And the last thing is we can also take our functions and replace our x or our variables with a specific value. So whenever you have a number in the parentheses rather than a variable or an x, okay, they're replacing that x with that number. So we've got f of 2 minus g of 2. So they're taking the function of f of x, so 5, and instead of putting an x there, they're saying plug in the value of 2. So we have 5 times 2 minus the function of g of x, which is x plus 2. And again, they're replacing that value of 2 with 2 as well, or that x with the value of 2 as well. And so then what we can do is combine. So we have 5 times 2 gives us 10. And then 2 plus 2, 4. And we're subtracting that 4. So we get 10 minus 4 is 6. Okay? So those are the ways these operate, right? You can do your basic functions. You can multiply them by a scalar. You can also substitute in the value that they give in the parentheses for your x, and then you just solve from there. So let's do a couple of these together. Let's look at number 1. I got f plus g of x. So this is another way that they can write them. So rather than saying f of x plus g of x, they're saying take the two functions f and g, add them together, and of course x is just our variable. Yes, I do. All right, up here. Notice this time our f of x is x plus 5. And our g of x is 4x. So they wrote it this time as f plus g of x. So we're taking the function f of x. We'll go ahead and put it in red again. X plus 5 plus g of x, and g of x is 4x. So what do we get? 5x plus 5.
Oh, I'm looking at the wrong one. I thought you were on the homework.
No, not on the homework. Not doing homework yet. It's number 2. We've got f of x minus g of x. So what does that give us?
3x plus
X plus 5 minus 4x.
Right, sure.
And that gives us, yes, negative 3x plus 5. And then our last one, we've got g divided by f of x. So the function of g of x, 4x, divided by f of x, which is just x plus 5. We can't reduce those any. Okay, so that would be our answer for number 3. Okay. Any questions on doing that ourselves?
Can you do like a division one where like it'll actually simplify?
Mm-hmm. Before we get to that, let's look at number 1, 2, and 3, the second set. So number 1, this time we have f plus g of 4. So they're saying rather than have the variables, we're going to plug in the value of 4. Now we already did f plus g, and that gave us that 5x plus 5. But then we're going to substitute in this value of 4 for our x.
Wait, where'd the thought?
Yeah, read the 5x first.
That's what F plus G is.
F plus g gave us this value, right?
So is it always going to be like that when it says F?
So like one problem goes into the next.
Not necessarily.
He's just bringing it up.
I'm just bringing it up because we're using the same values for our functions of f and g. So we had already solved for f plus g of x. So I'm taking that value and I'm plugging it in. Okay, so we've got 5 times 4 gets us 20, plus 5 gets us 25. Now the other way we can do it is we can take this value of 4 and plug it into our original function of f. And this is actually the easier way of doing it. So our original function of f is x plus 5. So I'm plugging in 4
That's 9. What was that? 9.
plus our 5 plus we have g. So g again was 4x. So I'm replacing our x with 4. We had that original 4 times x. So when we do it this way, 4 plus 5 gets us that 9. 4 times 4 gets us 16. And 9 plus 16 is 25. So when the value that you're plugging in is the same for both, you can combine the functions together and then plug in the value. You get your answer. Or you can take that value, plug it into each function, and then combine those two values from the two functions to then give you your answer. It'll work either way. This way is actually the little bit easier method, right? Because you're simplifying down an entire function to a single number, and then you're doing the operation between the two with those two single numbers. So let's do that one with number 2. Number 2, we got f of 2 times g of 6. So if we plug in 2 for x in our function of f, what do we get?
You get 7.
We get 7 times, we plug in 6 for g of x, what do we get? 24.
Wait, I'm so lost.
Okay, so we're taking the value of 2, plugging it into our function of f. F of x was x plus 5.
Okay, so
So
that
replace
was
that.
okay.
It gives us the 7. And then g of x is 4 times x. We replace the x with 6. So we got 24. Multiply those two together. We get 168. And then our last one, number 3.
Yeah, this fraction thing is.
So we got
Is that 158 or 160?
168. And then our last one, we got g divided by f. So the function of g of x, we've got 4 times x, plugging in -5. So 4 times -5, divided by the function of an f. So it'd be -5, that's our x value, plus 5. Now we can do the top. 4 times -5 gets us -20, divided by -5 plus 5 would get us 0. And we cannot divide by 0, so in this case it's no solution. Or it would be represented as a hole in the graph. Okay? Or an asymptote, really. That would be an asymptote. We cannot have -5 as a value. Okay. So that takes us to the homework. So let's pick a couple. Which ones do we want?
10.
Yeah, 10.
10.
What about 7? Can you do 7 too?
We're gonna do number 7 because I get asked that. Okay, so number 7. We've got f of n equals n cubed plus 1 plus 2n. And g of n is equal to n minus 5. And they want us to find f of -2 minus g of -2. And the easiest way to do that is let's take these two values, the -2, and replace them in for our n values in the equation. So let's look at f of n. If we plug in -2 for our n values, what does -2 cubed get us? Or what is -2 times -2 times -2?
-6. Wait, no, hold on, -8.
-8. So we have -8. So f of -2, we got -8 plus 1 plus, what's -2 times 2?
-4.
-4. So f of -2 is -8 plus 1 minus 4. What does that value get us? -8 minus 4. -12, and then plus 1, -11. Okay? So we have -11 minus, what does g of -2 get us? We replace our n with -2. So -2 minus 5 gets us -7. So we have a -11 minus a -7. If we have a negative,
Yeah.
it becomes a plus. So -11 plus 7. We get the answer of -4. Okay. Any other questions?
I think it's 10.
No, yeah, number 10. Number 10, we got g of t equals 2t squared minus 4t.
It's open.
So we got f of t, or g of t, and then f of t is 3t minus 2. And we're looking for g plus f of 1. So we're replacing our t values with 1 and then taking the function of g plus the function of f. So if we plug in 1 for g, what do we get?
Four minus four.
That's 0.
So number 10. If I plug in 1 and I square it, what do I get?
You're gonna get 4. 2 times 1 is 2, and 2 squared is 4.
You got to do order of operations. Exponents becomes before multiplication. So 1 squared
So,
Is 1
is 1 times 2
times 2.
is 2 minus 4.
Negative 2.
So we get negative 2. And then plug in 1 for f of t. What do we get when we plug in 1?
3 minus 2 is 1.
So we get 1. So we have g plus f. So we've got negative 2 plus 1. What do we get for our final answer? Negative 1.